Welcome everyone. Today I'm going to talk to you about my talk, Lessons from a Plugin Developer, how to extend Unreal when you're not Epic. So before we start, quick introduction. We have like three things. We have the engine, we have plugins, and then you have your game. If you're Epic, everything is awesome. You can edit the engine and plugins as much as you want. If you're a game dev, you can edit everything as much as you want. You can just make a source build. It's easy. If you're like me, like a plugin dev, things are a bit harder because you can just edit your code. You can just edit your plugin. So this talk is truly on how to extend Unreal without changing the engine. First off, the slides will be online. So if you need to, take any picture, this will be also displayed at the end. So no worries. Quick introduction. I'm Victor Careil. I'm mainly known for having made Voxel Plugin back in 2017. If you don't know Voxel Plugin, it's a volumetric landscape replacement for Unreal. We do mainly runtime support, but we also support static worlds. We've been doing this for a while. So we released Voxel Plugin 1 in 2018, and we've been working on Voxel Plugin 2 since 2021. It's like 3 of us full-time now. Voxel Plugin 2 is currently in beta, and will be available for a full release later this year. But if you want to try it, and I know some of you already did, you can already access the beta online. Quick introduction to Voxel Plugin, a few of our features. First thing we do is non-destructive edits. So these are like some voxelized static meshes that you can move into your terrain. And since it's like fully non-destructive, you can like move them 2 months later, everything will still work perfectly. We also do sculpting, so both in editor and at runtime. So you can have a player make a nice cave, or make like a map, make your game, anything you want with runtime terrain editing. Everything we do is fully volumetric, meaning you can make caves, you can make overhangs, you can make like full planets if you want to, you can make ring worlds, which is always a fun one to do. And we scale pretty well. This is like a real size Mars, so it's like thousands of kilometers, and it works just fine as you zoom in. This is also real time. We do runtime Nanite, so we generate Nanite geometry on the fly at runtime. We have support for Nanite tessellation. This is really good to get some nice detail on the ground, like over there. We also do runtime lumen, both runtime distance field and ray tracing support. Custom graphs, this is pretty neat if you want to like do a bit of noise or a bit of like customization. We also support PCG if you want to like spawn foliage on your voxel landscape. And lastly, it's a bit long, we support what we call indirect materials, meaning you can paint any shader you want anywhere on your landscape. And when I say shader, I do mean like a different material graph on different parts of your landscape, which I think is pretty neat, and I will be covering some of this today. So gist of it is we do a ton of stuff, and we do all of this as a plugin, meaning without changing the engine. So today my goal is to give you some insights as how to do some of this from a plugin on your side, and I think this will also be useful if you don't make plugins, just because we're going to cover a ton of stuff which is nice to customize, for instance, the editor UI. So we will have 3 main parts. The first part, which is going to take like half of this talk, will be about how to customize the editor UI. Like I said, this will be useful even if you don't make plugins. Lots of like good advice, I think, in this. Then we will have like a very, very short section on how to optimize collision cooking at runtime. And the last part of the talk will focus on how to hack the Nanite vis buffer, so more of a rendering section. Right. Let me drink a bit. So, first part, customizing editor UI. This is really like a big list of tips you can use to customize the editor UI. The first one, which I'm sure most of you already know, is property metadata. This is the easiest way to customize how a property looks in Unreal. A few common ones would be the edit condition. This makes it so like another property is disabled when you tick a checkbox. You can use inline edit condition toggle to move that checkbox to be next to the property, which I think is quite neat. If you use edit function hide, this will hide the property if the checkbox is false. Then you have the classic UI min, UI max. This is to have like a nice slider on your property. You can customize the display name. Truth is, there's like too many of them for me to list them all. What I recommend doing is checking this awesome website, unrealgarden.com. It's like the Bible of property metadata in Unreal. I would highly recommend like spending 30 minutes to just like go through all of them, know that they exist, because you might save a ton of time later if you ever need them. If you cannot do what you want with property metadata, you can use property customization. This is for like more advanced changes to the property UI. We have 2 types of property customization in Unreal. We have the property type customization. This is to customize structs. So it's mainly to customize the value UI. What I mean by value UI is the right column over there. So we can see that we have this like seed property, and then we have a custom UI on the right. The other type of customization you have is the detail customization. This is meant more for like objects, and it's meant to like tune the layout of like object properties. So you can like add buttons, you can add remove properties. So you can see on the right, we added like a custom bake button to our config category. Awesome. So we're going to dive a bit deeper into a custom property customization. My goal here is to show you that it's like actually pretty easy to make one, and to show you some of the basic things you need to make one. So we're going to use this struct as an example. So it's a simple seed struct with like a seed string inside. If we don't do anything, this is how it looks in the editor. So you have like my seed, and then you need to expand that, and then you have the seed string underneath. And what we would like is something a bit more like this, where we have everything on like one line, and you have like a nice text box, and next to it you have like a nice dice that you can click to like randomize the seed every time you click on it. So to do this, first on the header side, we have two main functions. We have the customize header. The header is this top row, so in this case like a regular vector. So you have both the property name and the property value. And then you have the children, like customize children, which is to add any property you want underneath that main row. In our case, we're just going to use customize header because we just want to customize that first row. So if we dive a bit into this, so it looks like this. The first thing we want to do is get a child handle to our seed string. So property handle is a virtual handle that lets you do a lot of cool stuff, mainly getting a value and setting a value. And it's pretty nice because it's going to like handle multi-selection for you, meaning that you have like if you have like a dozen objects selected, it will automatically like return the same value for all of them, and let you set the value for all of them at once. Over there, we use get member name checked. This is just a fancy way of typing seed, but it has a big upside of being like type safe, meaning that if we ever rename our seed variable, this will fail to compile, meaning we won't have like any hard to track issues. So once we have this like seed handle, the first thing we do is we customize the name content, which is like the left part of my property. And I say customize, but really we're just going to use a default value. That's what you want to do like 90% of the time. You don't really want to change the name of your property over there. So we just use create property name widget, and that's going to create a default text widget for our property. Then we need to customize the value content. That's like the right part of our property. There's a bit more code, but as you will see, it's like fairly straightforward still. The first thing we do is we make a horizontal layout. This is to have the text box and then the dice next to it. So first we need to make that text box pretty easy. We just first do like field width. This is going to make the text box as wide as we can, because otherwise it's going to be a bit too small. And then over there it's fairly straightforward. We just use the create property value widget to get a default widget for our text box. Then we add the dice. To do this, we first do auto width. This is to make the dice as narrow as possible. We don't want it to stretch too much. Then we use a fixed size, otherwise it's a bit too big. 16 pixels tend to be like a good trade-off in my experience. And then, yeah, we add the button, we do a custom style, and then we have the on-clicked lambda. That's what's called when you actually click on the dice. And over there, we do something fairly simple again. We just make a random string, and then we use our property handle to set that value. And like I said earlier, the property handle does all of the heavy lifting for you. It's going to handle like undo, redo, post edit, change, and all of that tricky stuff. Now that we have this customization, we do need to register it. To do this, that's like the way you're supposed to do it in Unreal. It's a lot of code. You need to like add this to like your startup module and then do register custom property type layout. What we did at Voxel Plugin is we made a custom macro to do this. It looks like this. So you just do define struct layout, and then you put your struct name and your customization name, which I think is like much easier to use. And you can just put this in like any CPP you want. So this is custom code. It's like open source, but we will also submit a pull request pretty soon, so we can have this on the engine side. Yeah, so quick takeaways. Truly, don't do a property customization if you don't have to. If you can do what you need with property metadata, it's going to make your life much easier. And to know what you can do with property metadata, again, check that website. It's pretty good. But yeah, if you do need to make a customization, it's pretty straightforward to make, and I would highly recommend doing that. It might take like an hour or two. It's going to save you a ton of time as you start using your property. All right, next up we have the widget reflector. This is to easily debug Slate UI. So it's pretty straightforward to use. You use that big like pick widget button. In this case, I picked the dice button. And what's really neat is that we can see where this dice was created. So it's really, really good to reverse engineer some like editor features, because you can just like check some UI on the editor side and see where it was made. To open this, you need to do Ctrl-Shift-W in the editor. And if you're working with the package games, this is still available, and you just need to type widget reflector in your console. If you do UMG, this is also a good way to debug UMG UI, so I recommend using this. Extending editor menus. Most editor menus in Unreal can be extended. So in this case, we added like a small voxel menu next to your play button. Editor menus makes it easy to add new buttons, to customize the editor. And I think it's a really, really good way to make your tool feel native, because instead of having to like dig like 10 menus to get where you want to be, you can just like do one click, which I think is pretty good. This is also fairly easy to do. The first thing you need to figure out is which editor menu you want to customize. So to do this, it might be a bit weird, but the best way I found to do this is to use tooltips, meaning that we're just going to like do a full text search for that to quickly add to the project tooltip in the code. And as soon as we do this, we can find where this code is. This, I think, is a great advice for a lot of things. Like searching for tooltips or like custom errors in the code is a great way to find, functions, properties, editor UI, where some message was sent. I highly recommend doing it. If you use Visual Studio, I personally use entry on source search. It's a really good like index-based search tool, which can like search through the entire engine code in like a few milliseconds. It's like really good to iterate quickly. If you use Rider is pretty awesome by default, so it does this by default, so you don't need to do anything. Perfect. So now that we have the engine code, two important parts. We have the menu ID that we need to remember, and then the section ID. And then in our code, all we have to do is extend menu instead of like register menu. We just feed the same menu ID, and then find our add section instead of like just add section, and this will like allow us to extend the built-in section. And then we can do anything we want. So in our case, we do add dynamic entry to add a custom entry to that section. Also, I found this out like 2 days ago, and I think it's pretty neat, but like I have not used it much. You can do toolmenus.edit1 in the console, and this will do something like this. It will add a nice edit button to all of your menus, which I think is really cool, because then you get something like this when you click on it, which shows you directly the like toolbar ID. Interestingly enough, it also lets you hide any button you want. So I guess you can use this to like clean up your editor UI. Again, I found this out like 2 days ago. I think it's pretty cool, but I have not used it at all. All right, next up we have notifications. I think notifications are pretty neat because they allow you to like send non-blocking messages. Please don't do like a big pop-up that I have to like take action on startup. Do like a nice, non-blocking notification like this. They are fairly easy to make. You just need to do something like this. So you make a new notification info. You set the title. You set the subtext, which is like the text below the title. You usually want to do fire and forget. This will expire your notification automatically after some time. You set that time using expire duration. I usually set success fail icons to false. If you set this to true, you get like a nice warning icon instead of like that Unreal icon on the left. Finally, when you add buttons, please be careful with this. I lost quite a bit of time on this. If you don't set visible in state, it defaults to like CS warning, which is not your default notification state, meaning that if you don't set this, your button will like not appear at all, which is very hard to debug. So yeah, if you want to save some time, always set this value to CS none. Custom thumbnails. I think it's pretty easy to argue if I show you this, and then I show you this, that custom thumbnails are critical to navigate a large number of custom assets. Thankfully, they're like fairly easy to make. All you have to do is inherit from like one of the engine class, like the default size thumbnail renderer, for instance, and then you can register your thumbnail in your startup module like this. There are like plenty of examples in the engine. You can, for instance, look at the static mesh thumbnail renderer. That's a good one if you want to like have a custom viewport in your thumbnail. I do want to point out that it's using some very old semantics. So you should probably replace the new and deletes that they do with some smart pointers like share pointer or unique pointer. It might save you some memory leaks and some tricky to track crashes. Next up, we have custom toolkits. So custom toolkits are to have custom UI when you open a custom asset. So for instance, we have a custom voxelized static mesh on the right. And you can see we have this like nice viewport when we open the asset with a custom detail panel on the left. This is unfortunately pretty hard to make in stock engine. It's like a lot of code to get anywhere. So what we did is we made an open source wrapper to do this. It looks like this. It takes like less than 50 lines of code to make a custom toolkit. All you have to do is inherit from like Voxel simple asset toolkit, and then you can just make a new asset property, and the type of your property will define what the toolkit is for. And then you can use spawn actor, spawn component to do like any kind of like custom preview logic you want in your viewport. So yeah, all of this is open source, so you can just check out this link if you want to use it. Almost done with this first section. So then we have custom graph. Really quick, custom graph I think are pretty neat. You can see most tools in Unreal nowadays are doing custom graphs, which I think is quite telling. Like making a domain-specific graph for your tool can really be of a great help. It is a ton of work, so I would recommend starting with some open source example. Don't start with the engine one, I think. Like a lot of them tend to be fairly complex. It's probably going to be easier for you to start with these two open source graph systems. All right, fixing linking errors. I'm sure most of you have already seen something like this, where you make a nice feature and then you compile and it just doesn't work. This is because in editor, modules are compiled as DLLs. So to use a function from a different module, you need that module to export that function, and you need to import that function in your module. Quick note, this is only the case in editor. If you have a package game, it's what's called a monolithic build, meaning we're going to build a single .exe. We have no DLLs, so this is not an issue in package games. So quick refresher on linking errors. Say you have an engine struct like this. You first have function A. Function A has the engine_API macro, meaning it's like exported, meaning that you can use it as long as you added the engine module to your build.cs dependencies. If you have function B is some inline code, meaning you can also use it in your code as long as all of the code inside that function is exported, because basically like the code inside of that function will be compiled in your module, so you need to be able to use all of that code in your module. Lastly, we have function C. This is, as you can see, not exported, meaning you can't really use this in your plugin. Except you can, just a bit of a mess. You have to do something like this, meaning you have to literally copy-paste the engine code to your plugin. Critically, make sure that the engine code matches perfectly what you copied. This can be especially tricky when you upgrade engines, because you might have copied like something in like 5.2, and in 5.5 it might have changed entirely. So you need to make sure to like update everything as you move engines. If you don't do that, this code will be used in editor, but like in package, it would still use the engine function, so you might get some tricky to track mismatches. For the same reason, we need to add is monolithic over there. Otherwise, you're going to get like duplicate symbols in package games. Last tip, which I think is pretty fun, is auto-access private members in private structs. So this is a bit of a classic one. You have like a my struct with a private instance value, and you want to access it. You have like three main ways to do this. The first way is we can be a friend of that struct. So we can fake being like some class, we can pretend to be over there. If we can fake being that class, we can access the private members because we have a friend. Solution 2 is to do hashtag define private public, because the C++ still runs the C preprocessor before any compilation. So you can like define keywords as much as you want. This can lead to some linking errors with MSVC, so please be careful. Also, I got like publicly shamed in the past for doing this, so I don't really do this anymore. What I do now is session 3, which is to use C++ template tricks. What I mean by this is that the C++ standard is broken, meaning that if you have an explicit template specification, you can access private members inside the argument of that template. More on this on the next slide. But do know that this does not work for private constructor, so if you want to access private constructor, you need to use session 1 or session 2 above. So yeah, so let's say you have like my struct, and you want to access your private my value member. All you have to do is use this like fancy define private access macro. You set your struct, you set your property name, and then let's say you have like some random function test, and you have my struct. All you have to do is do private access of my value on my struct, and then you have a full access in a totally safe way to my value. So you can set the value, read the value, do anything you want. Critically, define private access can be anywhere. So even if like my struct is in the engine, you can just do define private access in your own code, and it's going to work just fine. This might look like magic to you. It's actually fairly straightforward, if I can say that. All this macro does is this bunch of code. The important part is over there. This is where we like do the explicit template specification I was telling you about before. This is where we can like access this private member. So yeah, we also have like defined private access function. This is to access a private function. If you use Unreal and you don't want to use our custom macros, you can also just use the Unreal version over there. And yeah, if you want to check out how we do this, this is where the code is in our open source repo. So yeah, this is the end of this first section. So some takeaways. You can customize pretty much everything in the engine nowadays, like most of the editor UI you can hack into. If you don't know where to start, I would recommend looking for like an existing engine feature which does what you want to do. And just, copy paste everything. So find where it's defined using the widget reflector or using tooltip search like I was telling you before. And then, yeah, like I said, literally copy paste the engine code and iterate on it and do as much as you want with it. Perfect. So next, we have a very, very short section on how to optimize collision cooking at runtime. This is more to show you how you can like change some default engine behavior without making engine changes. So the issue is we do collision cooking on the fly for a lot of chunks. So if you look on the right over there, somewhere, every chunk, every color that you can see is a different chunk. And each chunk is like 32 by 32 vertices, so you have like thousands of vertices being cooked at runtime. And the collision cooker in Unreal is pretty fast, but it's more made for like offline use. So like for runtime use, it can be a bit slow for our use case. So how do we make this faster without changing the engine? So the way we do cooking is we use this chaos object, which is called triangle mesh implicit object. And we just use the default constructor. What that constructor does is it does like a BVH tree rebuild over there. And what we would like to do is replace this code with some custom code on our side. Sadly, if we look around, we can see that all of the other constructors are fully private, meaning we have no way to construct that object with some custom code that we made. But if we look around some more, we can see that we have some friends. So maybe we can fake being a friend of that class. So what we want to do is we want to fake being this guy over there. And the way we do this is like this. So first, we make a dummy class. This is just to ensure that we have no code collision with the engine. So this is like a purely dummy class. It's like only forward declared, instantiated. And then we do a fake specialization of our template. This will allow us to like access private members. Because since we are like now a friend of that class, we can do anything we want. We can access that private constructor I was telling you about. And we can now do custom cooking to make this faster. I sadly don't have time to get into how we do the custom cooking for Chaos today, but I would be happy to expand more on this later if you want to. But gist of it is we get something like this. So we start at the top before with like roughly 300 microseconds per cook chunk. And we are then moving to our custom cooking code, and we move to like 50 microseconds per chunk, meaning we just make this code roughly 6 times faster. If for any reason, I don't see why, but like if you do custom runtime cooking if you do custom collision cooking at runtime, all of this is open source, so you can also use this in your own code. So yeah, like I said, very, very short section. The last part that I'm going to cover today is how to hack the Nanite vis buffer in Unreal. So what we want to make today is something like this. This is just a tessellated plane, so we have like very few vertices on screen, and Nanite tessellation is handling a bunch of like heavy lifting. And we are then rendering different materials on a per pixel basis. So we have some sand over there, some rocks over there, some lichen over there, some other type of rock, and then some moss. So these are like fully different material graphs rendered on a per pixel basis. And if we zoom in a bit, we can also see that we get some custom smooth blends between these different shaders. So I'm going to show you today how you can do this in your own game if you want to. So it's going to be like a bit of a long process. So first I'm going to cover quickly what Nanite is, then how we can hook into the rendering pipeline, how we can make a custom complete shader in Unreal, how we can make what we call a mega material, how to extend engine shaders from a plugin, how to access render textures and render buffers from a plugin, how to fix any linking errors we might get, and finally, how to add those smooth blends I was just showing you. So first step, what is Nanite? As most of you probably know, Nanite is a virtualized geometry renderer. with automatic level of details. And the way it works is it renders into a visibility buffer, which is then shaded using compute shaders. So if we look at the image on the right, the way it's rendered is we first start with that virtualized geometry I was telling you about. We rasterize this into a vis buffer and a shading mask. The visibility buffer is made of two things. It's made of some depth and then some triangle ID, which is used to uniquely define which triangle is rendered where. On the shading mask side, we end up with something like this. It's basically like a buffer of like material ID. So each pixel is like, hey, I'm like this material, or I'm this other material. What Unreal then does is it dispatches custom compute shader per pixel to shade all of this into the classic gbuffer to give us our classic gbuffer variables, so stuff like the color, the normal data, or the roughness. What we would like to do is hook in between those two stages to add a custom material selection pass. What this would do is it would hook over there and change the shading beans before we shade them to have per pixel materials. So to do this, we first need to find where we want to hook. The easiest way to hook into the render pipeline in Unreal is to use what's called scene view extensions. They look kind of like this, and they allow you to hook into mainly three places. You can hook before the base pass, after the base pass, and after all of the post-process passes are run, which might look fairly limiting, but in practice, it's been mostly fine for everything we want to do. You can still do pretty much everything with these three places. In our case, we want to hook in pre-render base pass, because the vis buffer is computed before this, and base pass, in our case, is going to be where shading will happen. So we want to hook right before it's done. So now that we know where we want to hook, we need to find what we want to inject at that stage. So we need to add a custom compute shader. There are like three main types of shaders in Unreal. You have the global shader. This is like a more of a pure HLSL math shader. So you're going to find like the ambient occlusion shader. You're going to find the bloom shader, the SSR shader. All of these would be like global shaders. You then have material shader. These are like an HLSL shader merged with a material graph. So the HLSL shader can query the material graph properties. So you're going to find the post-process shader in this, the decal shader, the slate shader. All of these are like shaders which are tied to a material to query the material properties. And lastly, we have the mesh material shader, which is a material shader, but tied together with a mesh, so with a vertex factory. So basically, the material shader can then also query the mesh data, so like the per vertex data. And that's where you're going to find the base path shader, so that's what's going to render like pretty much everything in Unreal, the velocity shader, the lumen shader, all of this. So if we look at our use case, what we want to do is we want to select materials based on displacement values, because we are doing some height-based blends. In our case, displacement is set in like artist-authored materials, so like artists are setting some custom textures to do displacement. So what we need to do is we need to make a material shader. So I won't go too deep into this, but the gist of it is we need to make a material selection.usf. USF stands for like Unreal Shader file. In this file, we're going to include the generated material.ush, Unreal Shader header file, and this file will be generated by Unreal for every material that we have. So for every material like this that we have, Unreal will compile the material graph into this material.ush shader. And yeah, like I said, we are going to do this for every material that we have. Once we have all of this, Unreal will generate a permutation of our shader with every material that we have to make specialized version of that shader for every material, like this. And that's the gist of what a material shader is. In our case, though, we have many different materials, but we need to make a single compute shader because, like I showed you before, we can only hook at one place and we don't want to like do 1,000 dispatches, so we need to merge all of this into like one shader. To do this, we are doing what we call a mega material, which might look a bit scary at first, something like this. So what we do is we literally copy all of the material graph into this big material graph. This is done automatically. This might look very bad for perf, but it's not too bad in practice because we have this bit of a magic node on the right. What this does is it does actual branching between the different material graph, meaning that you only end up computing one of them at one time, so it's really not that bad and perform pretty well. The only limitation you're going to see is on the SRV side because you can only bind so many textures to a single material. These are like purely arbitrary limitation on the Unreal side and don't really affect perf. So we use this for displacement. To compute displacement, we use this to compute like lumen data, so like color and everything. We use this to compute ray tracing data, to compute runtime virtual textures, to render on mobile. So basically, everywhere we cannot use like a screen space trick with Nanite, we have to rely on this backup, which is the mega material. Next up, we need to extend some engine shaders because we do need to make some changes to the engine. So I guess I lied, because earlier I said we do all of this without changing the engine, but we actually change the engine. Because yeah, plugin cannot edit engine source because C++ is precompiled, so there's no way for you to change that on the fly. That being said, when it comes to shaders, shaders are compiled like all of the time, so you can actually change engine shaders at any point you want, and then just restart the editor and it will like recompile as needed all of your shaders. So yeah, plugins can like open a file, make the change they need, save that file, and it will recompile. So we made this into a bit of a cleaner system, which we call shader hooks. It's like a GUID and diffing-based system. So the way it works is you can define one like this with like this add shader hook macro. The first thing you do is define a custom GUID. This is to make it easier to track where your shader hook is inserted. Then you can set your file name, the code that is before the code you want to insert, the code that is after the code you want to insert, and then the code you want to insert in between. So it's like a fairly robust system because it's like diffing-based, meaning that even if you make like some light change to your engine source, we will still be able to like patch stuff as needed. We then have a very nice, I think, editor UI to like update shader hooks, remove shader hooks, do anything you want with them, which makes it very easy for like even non-technical users to upgrade their Voxel Plugin install or to remove any custom hook we might have added. So yeah, with this we can edit any engine shader, and all of this is also open source. So if for like any reason you need this in one of your plugins, you can just steal this code over there and make use of this. Another thing we need to do is we need to get access to the visibility buffer if we want to like be able to edit it at all. Sadly, it's not exposed by Unreal, which usually means game over. So as a plugin dev, you're going to like spend a full week doing research. It can be like super nice. You're like, I have this like super nice idea. I can make a ton of very cool stuff, and then you can't because the thing you need is actually not exposed, so you have no way to do this. In this case, we can rely on a small trick, which is what you can turn right, which is that the graph builder stores a list of all of your render textures and all of your render buffers with their debug name. Critically, the debug name is also stored in shipping. So what we can do over there is we can just iterate over all of the textures in our graph builder. And for every texture, we check if the name matches what we want to find, and if it matches, we can just steal it. And as you can see, we make use of the private access that I showed you before to do this. All right, last step, we need to fix some linking errors. This is due to the Nanite uniform parameters not being exported. There's no magic over there. We need to do what I said before, which is to define the function from Nanite in our own code, so like copy-paste. In this case, it's a bit trickier than this because the Nanite functions are actually like defined by macros, and it's a bit of a mess. So what we have to do at the end of the day is something like this, where we make use of the engine reflection for like shader metadata to access the data we need. This is extremely hacky, but it does seem to work very well so far, so I think it's perfectly fine to use in production. Awesome. So once we have all of this, we get something like this, which I think looks pretty good. You have like per pixel materials. We can confirm this by checking the shading bin view on the Nanite side. So each pixel is assigned a different material. You can see we have like very precise boundaries. If we zoom in a bit, though, we can see we get some pretty sharp edges between the different materials, so like over there and over there. We would like to get a bit of a smoother blend like this. So to do this, we make use of dithering. So what we do is we simply randomly switch on a per frame basis between different materials. This is how it looks with no TA applied and no TSR applied. Once you apply a TSR and TA, I mean, you know it is nowadays, everything looks good. So we have this like nicely blended result. To do this, we weight the random selection based on our eye blend, which means that we get very nice smooth blends as you get like from one material to the other. Critically, this still renders like only one material per pixel per frame, so it's still like super fast and the same cost as before. We get this like free blending for free. So yeah, so some takeaways on this last section. Making material shaders is pretty easy, and it allows you to give artists full control. So I'm more of a graphics engineer myself, and I work with a tech artist. So what I usually do is I do some fairly tricky, or like what I consider to be fairly tricky math in HLSL, and then I expose all of the required function to my artist in a material graph. That way I can focus on making everything look pretty on the material side, and I can focus on making it fast on the backend side. So I think if you're in a team with graphics engineers and artists, it's a really, really good tool to have to collaborate like this. Like I said before, you can hook into most part of the rendering pipeline, which I think is really good. When I started like 8 years ago, it was not the case, and it was much harder to do anything. And you can access most render textures and also render buffers using the trick I just showed you. I made an open source example from all of this. So if you want to get into material shaders, you can check this code on GitHub. This also covers how to hook into the Nanite Vis buffer, so feel free to look at how this works. It's a fairly small amount of code. I think it's like 700 to 800 lines. So yeah, if you want to get into it, it's probably easier to check this out than to try to dive into Nanite or some more advanced feature on the engine side. What this sample does is something like this. So on the left over there, we have a plane under with a single material, and we then replace that material with some custom material switching. So on the top right, you can see this material graph. This will like decide which material to render on a per pixel basis. So just outputs an index, and that index is then used in the array below to choose which material to render. So yeah, if you want to get into material shader, you might want to check this out. Perfect. So this is pretty much it. Some conclusion. Like I said, there are many ways to customize the editor UI. Don't feel like you're going to be blocked. You're going to be able to do pretty much anything, just a matter of finding how to do it. You will encounter private variables a lot of the time. Again, don't feel blocked. You can just bypass that with a few tricks. It's fine. Same if you have any function which is not exported. You can probably copy the code of that function to your own code, and it will be fine. Do be careful with this, because sometimes you might start copying some code and then copy more code and more code and more code, and you end up with like a ton of code copied from the engine. If you get to that point, it's probably time to like redesign your thing to be a bit different and not use the same functions. Yeah, like I was again saying before, you can hook into most part of the rendering pipeline, so that's fairly easy to do. And lastly, which I think is most important part, is arcs are fine. Just make sure you like wrap them into like a nice function, so you don't like bleed to use the rest of your code, because it's just going to like, make everything a huge mess. But using arcs are totally fine as long as they work. You're good. Small thing before we end. Voxel Core is an open source part of Voxel Plugin. It's like MIT licensed. Every time I said during these talks that we had some stuff open source, it was part of this plugin. We also have a few highly optimized containers in this if you're into like hyperf containers. So for instance, we have like a map, which is I think 40% faster than the stock engine map, while being smaller in memory. We have a bit array, which can be like up to 6 times faster. We have a sparse array, which can be up to 7 times faster. We have some custom array class, like the remove at swap function in the engine is currently broken. It's like 3 times slower than it should be. I just need to do a pull request to fix this. But yeah, gist of it is like if you want some hyperf code, you might want to check this out. It might help you a bit. Same if you want to like do some custom editor stuff. We have a ton of like editor helpers. If you want to like make custom toolkits, like I was telling you before, custom details, you can check this out. You might save a bit of time. And that's pretty much it. So yeah, this is my website. If you want to check out the slides, you can just go over there. That's what the QR code is for. You can check out our website if you want to learn more about the plugin. We have a Discord if you want to check out our Discord. This is the Voxel Core repo. And lastly, I'm like Fiona's on Twitter, Blue Sky, and Discord. I think we started this session a bit late, so we probably won't have time for any questions. Maybe one question. And otherwise, I will be at the Dev Hub after this if you want to discuss some more. Thank you.
Hi there. Hello? Yeah.
Yeah.
Yeah, I find it really impressive that you managed to get all these changes in without any engine mods. How hard has it been to maintain this plugin that way? Because I would imagine from version to version, you'll have major changes.
Yeah, so that's always something that can scare people off, is like how much the engine changes from one version to the other. In truth, it's been fairly good for us. My advice would be to make wrappers, because when you have wrappers, like the amount of code you need to fix when you upgrade engine is like very small, and it's limited to like these wrapper functions. So nowadays, like upgrading to like latest engine takes us like, what, 4 or 5 hours of work at most. So it's really not being too bad for us on that side.
Nice. Thank you.
Perfect. So yeah, I will be at the Dev Hub, or like the Dev Lounge, I think, if you want to discuss anything else. Thank you.